Okay, fine. So this is the agenda. Actually, we have started in the last class. Just I have set the agenda, and I have told you, like I have given the Spark overview in the last class, and as I have committed that we'll continue from this class onwards. Okay. So you can see this is the agenda that I have set. So Spark overview we have completed in the last class, and today we will continue from the next topic onwards. That is Spark versus MapReduce, Spark ecosystem, Spark architecture, Spark API, Spark installation, introduction to Spark RDD, creating RDD, operation on RDD, transformation operation, action operation, and legit evaluation as well. Okay, so these are the things we need to continue today. So good. Okay. Now, what are the disadvantages of a Hadoop? As we have explained in the last class. So Hadoop is meant for to solve basically two different problem statements. One is for storage, one is for processing part. Now coming to storage, basically, so you can see, so HDFS we are using, okay, Hadoop distributed file system. And coming to processing part, we are using MapReduce, okay. But there is no problem with HDFS. I don't have any concern, any complaint against HDFS. HDFS work absolutely fine, great. Even nowadays also people are using HDFS in the real time, like in the production environment and all. Now coming to MapReduce, guys, there are a lot of disadvantages. What is the first one? MapReduce is basically written in Java program, as we have seen in the last class. And Java program is not that much easy, as you know, it's a little bit complex because I have to write lot many lines of code just to print a statement. Okay, but in Python, I just simply write a one statement that is print. Inside that, whatever I will write in the string format, it will print. And a part of MapReduce, basically, I am writing three different Java files. One is in mapper.java, a reducer.java, and main Java or driver.java file. Last class we have seen, right? Now, when I am executing these three Java file, it's taking a lot of time for processing and all. Okay, that's why it's not efficient. You can see even if I have drawn a beautiful component, so whenever giving input file is going to the splitter component, then splitter to mapper, which is nothing but a mapper to a Java file, then combiner, partitioner, then it's going to reducer to Java file and all. Then I'm able to see the output. So you can see it passes through almost 4 to 5 different stages. Then only I am able to see the output. So obviously to pass through each and every stage, processing the input data, it will take a lot of time, right? That's why efficiency is not that much fast. That's why to overcome the issue that I'm facing in the MapReduce, one of the beautiful another platform or services come into the picture that is called Apache Spark. Basically, the framework name is called Spark as the company Apache, created this product or a platform. That's why people are calling this one is Apache Spark. So Apache Spark basically is a processing engine. So processing part, it does not have its own storage layer. Again, for storage layer, it rely on HDFS. You have to store the data on top of HDFS. But for processing part, you have to use on Spark. Okay, so Spark is meant for processing part, not the storage part altogether. Clear, guys? Any doubts so far? Any doubts so far? Now, let's see. The next one is, let me go back. Yeah. Now, coming to Spark, guys. Let me change the color. Now, a typical Spark framework looks like this. Why it is more popular? That is a strong reason behind it that I am going to explain now. Guys, it has different module to complete different tasks. Try to understand. It's very important, guys. So let me draw the diagram first. Then I will explain each and everything. Okay. Okay. Now the core module of Spark framework is Spark core module. Let me write down one by one. Okay, this is called Spark core. So this is typically the architecture of a Spark. Let me give the heading. Spark module. Different module. What are the modules present that we are going to discuss? Okay. So there is something called Spark core module. All the other modules they just resides on top of this Spark core module. Okay. All the other module like something like that. Spark. Okay. SQL module. I'll explain each and everything. Then Spark. Streaming module. Spark. MLlib module. Spark. Graphics module. Then the last one is Spark R module. Guys, what is this? As I told you, these different modules are meant for to complete different specific tasks. The task for which you can use the Spark skill module, you cannot complete by using Spark streaming module. These are represent the specific task. For example, there are two different type of job we run in the production. One is batch job, one is streaming job or streaming data processing. To process, okay, let me change the color. To process batch job, basically or structured data, CTU or structured data, I'm using Spark SQL model. Similarly, to process streaming data, I'm using a module called Spark Streaming Model. Similarly, you might have seen there is a new job profile called machine learning data scientist and all. To process machine learning application, I am using Spark MLlib model. MLlib module. It stands for machine learning library. ML stands for machine learning, right? Machine learning lib. Lib means library. Libraries. Similarly, to deal with a graph application, to repair graph, different data structure, like tree data structure, graph data structure, and all. To process graph related task, I'm using graphics module, Spark. Similarly, what is R? R is a kind of functional functional language, basically. Okay, programming language. Like how Python is a programming language. Similarly, a standalone programming language that is called R. R programming language. To deal with R programming language, I'm using Spark R module. And all these modules are supported by the base module that is called Spark core module. Means I can say the father of each and every module is called Spark core module because you can see each and every module resides on top of the Spark. Is think about a you are building a house. It's a kind of base, concrete base. Then on top of that you are making the floor. So this is the base module, Spark core module. Clear, guys? Any doubts so far? Going forward, we'll see what are the different components that are related to this module. Like we have something called RTT, data frame, data set, and all. Everything, each and everything we'll see as part of this discussion. You can see creating the RTT, introduction to Spark, RTT, and all transformation action. I will explain. Okay. Now all of you clear to this point, kind of introduction part. Clear. Now the time has come to enter into Spark versus. So this is the Spark ecosystem actually I have completed as part of this architecture. And architecture both are same actually. Okay, ecosystem. I'll show you in a PPT. Now Spark versus MapReduce. More or less I have already explained what is the difference between them. But officially let me show you the PPT, the difference and all in a tabular format. Okay. So guys, any doubts so far, please let me know. Okay, so this thing I have just explained. Now see, these are the different Spark overview as I told you. Like we have something called graph processing, streaming processing. For ETL, basically this is Spark SQL module, machine learning library and all. Okay. Now see, difference between MapReduce and Spark. Now see, MapReduce. It is a framework that is open source which is used for writing data into the Hadoop distributed file system. It is an open source framework used for faster data processing. As I told you, why is it faster? It is having a very slow speed as compared to Apache Spark. It is much faster compared to MapReduce. It is unable to handle real-time processing. I told you last class. By using MapReduce, I can deal with only batch processing, but I cannot process the real-time data. But by using Spark, I can deal with both batch processing as well as real-time data. Why? Because I have two different separate modules. To deal with the batch processing, I have Spark SQL module. To deal with the streaming data, real-time data, I have streaming module always. Clear? Now, it is difficult to program as you require code for every process. Here it is easy to program. Why difficult? Because last class you have seen, just to write the number of word count in a paragraph, I am writing three different Java file. Mapper.java, reducer.java, main.java file. That will lengthy code because I'm writing all in Java code. But in Spark, if you want to do, it will not take that much time and you don't need to write that much heavy code also. You just have to write a single file, not three different file. And that too, it is also giving a provision. You can write any programming language. Okay, any programming language since you can use Java or Python or Scala or R or anything else. Okay, now it is support more security project. Its security is not as good as MapReduce and continuously working on its securities. Okay, that is only kind of demerit I can say of Spark over MapReduce. Now, for performing the task, it is unable to catch in memory. It can catch the memory data for processing its task. Its scalability is good as you can add off to any different node. It is having low scalability as compared to MapReduce. It actually need other queries to perform the task. It has Spark SQL as its very own query languages. Fine. Now, this is Spark ecosystem, guys. Like in the Hadoop, we have seen different components were there, like have a Hive, HBase, then I can say Peak, HDFS, MapReduce, and all. Similarly, Spark ecosystem is a collection of open source projects that are built on top of the Apache Spark. These projects extend the functionality of Spark and make it easier to use for a variety of tasks. Okay, you can see I can deal with Spark Apache Cassandra to interact with Spark. I can use JDBC ODBC connection. I can use any file format that is Spark Q, Abro file format or not. I can integrate Apache Hive HBase with Apache Spark. I can integrate Apache Mesos, Hive, Yarn, HDFS and all. These all are Hadoop supported component which I can integrate with this Apache Spark and I can work on that. Clear, guys. Guys, I'm just getting a call. 1 minute. Yeah. So you can see the same things whatever I've written in the whiteboard is written here. Spark SQL. Spark SQL is a module that provides SQL support for Spark. This makes it easy to use Spark for data warehousing and data analytics tasks. Now, MLlib is a module that provides machine learning library, okay, for Spark. This makes it easy to train and deploy machine learning models on Spark. Now, GraphX is a module that provides graph processing libraries for Spark. This makes it easy to process graph on Spark. Now, similarly, streaming module. Spark streaming is a module that provides streaming processing capability to Spark. This makes it easy to process data streams in real time. Now, Delta Lake. Delta Lake is a project that provides a unified data lake, storage layer for Spark. This makes it easy to manage and query data in a data lake by using Spark and all. So this is the Spark architecture, typical architecture. This is the architecture how it work internally. Whatever I have drawn, that is the architecture of a module. But if you see how the Spark architecture looks like for job flow wise, then it looks like this. So you can see we have something called master node. It's same as a Hadoop architecture only. We have the master node, we have the worker node. So inside the master node, we have driver program in which Spark context will be executed. Then there is something called cluster manager. Okay. Then this cluster manager will interact with the worker node. So inside worker node, we have something called task and catchy. Inside word catchy, basically the task will execute, and we have something called application master. Then every 3 second or 10-second interval, my resource manager, a node manager will give the response to cluster manager, resource manager. Then the response will come back to the driver program and the output will be displayed. Like it will be the same flow like what we have seen in the Hadoop itself. Okay, clear guys? Any doubts so far? Any doubts so far? Spark APIs. Let me write down. Now coming to Spark API, guys, first of all, as I told you, Spark provides the API in 4 different languages. That's the beauty. I mean, you can write your Spark framework or application by using 4 different programming language. That is called Java, Python, Scala. Another one is called R. So whenever telling Spark API, think about is related to I'm just going to discuss about the Java API, then Python APIs, Scala APIs, and R APIs. But coming to Spark API, basically, there are 3 different things. One is called RDD, second one is called data frame, third one is called data set. Okay, RDD, data frame, and data set. Clear, guys. Then what is RDD? What is data frame? What is data set? That we will discuss one by one. Not an issue. Okay. Now coming to RDD, I'm just giving some glance. Then we will discuss extensively when we will enter into the particular topic that is here. creating RDD, operation RDD and all, each and everything we'll see. Okay, introduction to Spark RDD will start now. Now just I'm writing. The RDD stands for generally the full form of RDD is resilient distributed data set. Resilient distributed data set. I can say this is the core data structure of Spark framework. Is the core, or I can say fundamental object, or I can say data structure of Spark framework. Now, what's about data frame? Data frame basically, if you want to represent the data in the tabular format, basically, if you want to represent, if you want to represent data in tabular format, we use data frame. Similarly, what's about the data set? Data set is nothing but a combination of more than one data frame. Okay. When we will enter the particular topic, we'll see. So it is the combination of, guys, just 1 minute. Yeah. It is the combination of more than one data frame. Clear, guys? So now we understand, coming to the Spark API, basically there are three different API. Mainly, this is the language wise, whatever implementation we can do. But coming to Spark API, basically three types. Let's RDD, data frame, data set. Clear? Now let's move to the next one. Spark installation. Okay. So we'll see how we can install the Spark in our machine. Okay, how we can install the Spark in our machine, then how we proceed and how we can write the code in our machine. Okay, Spark installation. Any doubt so far? Please let me know. Okay. Coming to Spark installation, guys, there are different steps are there. Let me write down all the steps, then I will discuss one by one. Okay. So the first step is, let me write down all the steps first. Okay. First step is download Apache Spark. You have to download the Apache Spark software, or software from the internet. Okay. Download Apache Spark software from internet, obviously. Then the second point is, guys, you have to set environment variable. Okay. Set The third one is basically configuration. You have to do the necessary configuration. Now after configuration, guys, it's like start a Spark cluster. Okay. Okay. Start a Spark cluster. Now the verify the installation, whatever installation you have done, you have to verify. Let me scroll off. Okay. Verify the installation. Then once you verify the installation, then we have to stop the Spark cluster, whatever we have started previously. Stop Spark cluster. Okay, that's all. And obviously, so there are different mode. We'll start here in the standalone mode, and we have to stop in the standalone mode itself. Standalone mode. Here also, while stopping, you have to stop in standalone. That's all. Okay. Any doubts so far, guys? Any doubts so far? Okay. So now coming to configuration, guys. So there are different configuration files are there by using which we can do. So when we will enter into that particular point, I'll explain. Okay. So let me share my screen. I will explain what are things I have written in the whiteboard. We will go by one by one. Okay. So till this point, any doubt, guys? Let me. Spark provide API in four programming languages, as I told you: Java, Scala, Python, and R. Okay, but coming to Apache Spark API, it's three types. One is RDT, data frame, and data set, and everything we'll see in depth going forward. Okay, now you can see. So correspondingly, as we are using four different languages to write the Spark application. So we have four different API also: Java API, Scala API, Python API, and R API. Just have a look for 1 minute. What is written here? So Java API is the most mature API of Spark. It is designed to be easy to use of Java developer. So if you know Java, yeah, you can go ahead and write the Spark application using Java. Then Scala API, the Scala API is a superset of Java API. It provides additional features that are not available in the Java API. I mean, basically, you can deal with, if you're, convenient in Scala, you know Scala, then you can go ahead and write the Spark application in Scala. Similarly, if you're a Python developer, happily you can go ahead and write the Spark application using Python and similarly R. Now, the Spark API are all similar in terms of their functionality. Whether you are using Java programming language or Scala programming language or Python programming language or R programming language, functionally wise there is no difference. It's telling all are similar in terms of their functionality. Just coding, syntax will be here and there a little bit. They all provide the same basic operation for creating RTD, running job, accessing data, and all. Here, now, see, what are the steps? First, as I told you, you have to download the Apache Spark. So to download, there is official website. That is www. HTTPS www. Obviously spark.apache.org. Download HTML. Once you click, you will see there is a pre-built package in the form of jar file, a tar file you can say. Spark version will be written, let's say 3.2.5, something like that. Then Hadoop version, then you have to just click it, you have to extract, just right click extract as a tarball file and people location. Keep it in a D drive or E drive or wherever it may be. Okay. Now what we'll do next step, as I told you, set environment variable. Yes, this is optional, but if it is optional but recommended process, better to do it. Okay, what I'll do basically open your cell profile configuration, that is a bash file. Basically, this is a Unix command altogether. Add the following link, lines to set Spark later environment file. So generally, you have to run this file, otherwise, or else you can set this path in the environment variable in the Windows if you are using Windows OS. Now replace path to Spark exactly where is Spark you have installed. That is D drive or E drive. That location you have to keep. Okay. Now configuration. Spark configuration setting are typically stored in the Spark default configuration and Spark environment setup files within the configuration directory of your Spark installation. You may need to adjust this file to suit your specific requirement. Okay. Start a Spark cluster, that is standalone mode. You can start a local Spark cluster to for testing and environment purposes using the following command. You can see how to start. So you have to go to that Spark home folder, sbin slash start hyphen all.sh. Okay, clear. This command start the master and worker node on your local machine. Similarly, once you start, how to verify the installation whether you have installed successfully or not? Open the terminal, that is command prompt. Just write spark hyphen cell and click on enter button. You should see the spark cell prompting, just some message going up indicating spark is running. Okay. Once you will see that type of message, then you have to stop. How to stop? You have to stop in the standalone mode. Why? Because the mode at which you have started, that is standalone mode. Same mode you have to stop it. Now, what is the command for starting? Spark home is been start hyphen all dot sh. Similarly, while stopping, you have to write spark home has been stop hyphen all dot sh. See, stop hyphen all dot sh. That's all. Now, clear, guys. Any doubts? So, any doubts? So, now the time has come to see introduction to Spark RTD. This is very important. Introduction to Spark RTD. Okay. I hope all of you are able to see my screen. Quite good, right? Okay. Fine. Now, guys, when I tell you RTD, as I've written the full form of RTD in the above, that is a resilient distributed data set. There is a meaning of each and every word. What do you mean by resilient? What do you mean by distributed? What do you mean by data set? Anyhow, let me start one by one. Let's start with first resilient. Resilient is just similar to kind of fault tolerance. Resilient means, for example, any of the node goes down, it has the capability to recover back by its own. You don't need to do any manual switch up and switch on to make it off and down. So that is called resilient. Okay. Distributed means we have extensively discussed in the Hadoop ecosystem, HDFS. Hadoop distributed file system. What do you mean by that? It is present in different location, or it's just connected with a master node, and communication is happening through master nodes in a distributed fashion. So it is not single point of contact. Even though one data node goes down, the replica of the data that I have stored in that particular data node, same replica is available in other data node. Why? Because I'm maintaining the replication factor as 3. Everything in the internal architecture we have discussed extensively in the Hadoop ecosystem. This is the meaning of set. And what do you mean by data set? The third one, data set is nothing what I have written here. It is a combination of more than one data frame. That is data frame. Then what is data frame? It's in here. If you want to represent any structured data in the tabular format, then I can store in the data frame itself. So that is the meaning of RDD. That is a resilient distributed data set. Now, coming to is an operation creating a data operation. Okay, that is the different case. Okay, let me go through that first. Now, any doubt, introduction part, guys. I'll show you the PPT with beautiful diagram. By that time, will be 100% clear. Okay, any doubt till now? Creating the RTD. Okay, creating the RTD. Creating RTD. How we are creating the RTD? Let me explain each and everything in the whiteboard, then I'll go to my PPT and I'll show you each and everything. Okay. Creating RTD. How to create the RTD, guys? To create RTD, basically we are following 4 to 5 different way. Let me write down each and everything. Okay. Then I'll explain one by one. Clear, guys? Now the first one is parallelize an existing collection. So basically I'm using a parallelize method. Let me use a different color. I'm using a parallelize method. Basically, let me write down it directly. So I'm creating the object of Spark context. On top of that, I'm calling a parallelize method. P-A-R-A parallelize, L-L-I-Z-E, parallelize method. And inside that, obviously, I'm passing something. By using this method, I'm able to create the Spark entity. P-A-R-A-L-L-E-L-I-Z-D. Okay, yeah. Then I'm passing some argument inside that, then I'm able to create. Now, the second way is by loading a file. I'll show you the example, nothing to do with it. Okay, by loading a file, any file, it may be text file, CSV file, whatever, like, doesn't matter for me. Okay, loading a file. But generally, we do prefer, for that, I'm using a method called text file. Okay, fine. Then the third one is I can create RDD from an empty RDD. For example, I have a existing RDD. Think about the first one. I have created RDD here. From this RDD, I can create RDD, or from an empty RDD also I can create another RDD. So from empty RDD. So from empty RDD, I am creating the RDD. Okay. Then the fourth step is what I can do. Creating RDD. Okay. From empty RDD you are able to do. From empty RDD. From existing RDD you can do. For example, here the first step you have created RDD. Right? The output is RDD, right? This one, first step. Can I create the RDD out of this RDD? That means from existing RDD, I am able to create a new RDD also. So this is the beauty, guys. Okay. Then fifth step. What's the fifth step? I can create the RDD from a database also. So from database, like for example, I want to extract the data. Can I create the RDD? Yes, happily you can create the RDD. Okay, happily you can create the RDD. So from existing, sorry, not from me, from the database. So while extracting the data or loading the data, gathering the data from the database, there is an option also we can create a RTDM. Okay, so these are the different way how we can create the RTD. Now try to see each and everything, each and every category one by one. Okay, now let me discuss one by one. So till this point, guys, any doubt, any problem? Let me see. Any doubt, any problem? Explain each and every step, then we'll go to PPT. Okay. Now, first one is, sir, by using parallelize method, how you are creating the entity? Okay. Let me write down by using the first one. Let's say this is point number A. By using SC dot PARALLE parallelize method. Okay, I'm creating the entity. Okay, let me scroll off. Okay, guys. Sometimes before, when I was showing the Spark architecture, you might have seen that is, I told you, like there is something called Spark context. Have you seen Spark context? CONTEXT. It is present inside the master node or driver program. I told you, right? If not, then I'll show you the picture one more time. When I will uh, I will just enable, or I can show you my PPT. Okay, it is present inside the master node. The diagram was like this, right? So this is my master node, or I can say driver program, right? You have seen such type of diagram, right? Then something like node manager, sorry, resource manager. Then there is something called worker node, right? You might have seen such type of diagram, right? I've shown you. I'll show you one more time. So I'm talking about this Spark context. So this is the heart of the driver program. Basically, we are creating the object of this class, and whatever the operation I'll do on top of that object. Basically, what I'm doing, I'm creating an object that is SC. In short, I'm writing SC, Spark context is not equal to, is nothing but Spark context. I'm creating the object of Spark context class. Then on top of that, I'm calling SC dot parallelize method. PARALLELIZ parallelize method. Then I have to pass. What I will pass? Anything, any sequential value. For example, let me pass the integer value like 1, 2, 3. Then whatever things it will create, this is called RDD. So let me denote RDD1. Why? Because I have to create in 5 different ways. Let me name it RDD1, RDD2, RDD3 and all. Okay. So what are the output I am getting, that will be represented as part of RDD1. Clear, guys? This is how I can create by using parallelize method. So first I have to create the object of a Spark context class. On top of that object, I will call the parallelize method. Then I'll pass any data structure. Here I'm passing the list data structure. You can pass set, tuple, whatever name. Okay. Then whatever the output I'm getting, that is in terms of entity. Now the second one, by loading a file. The second one is how to do that. So I have created the object, not an issue. As I told you, this is very, very important. So this step, let me make it box. Very, very important step, because all the 5 steps or 5 different way, whatever I will follow, I will use this Spark context object. So this is very, very important. Very, very important. Because here I'm using SC dot parallelize. Here also same. I'll use SC dot. I have to load a file. How to load? I mean read a file. So Basically, I'm using a method called text file. The method name is text file, and you pass any file name. For example, employee dot text. That's a text file. And whatever the RDD will return, let me rename that as RDD. Name that as RDD, because here is creating RDD1 another way. I'm using text method here. Text file method to create the RDD. This is the step number 2. Now, step number 3. Sorry, why is not changing the color? Yeah. What is 3? From empty RDD. Okay. From guys, are you able to understand or not? From empty RDD. So from empty RDD, how I'm going to create a new RDD? Let me see. What is the process for that? What is the process for that? Okay. Example, like same thing. I will take the object of Spark context class. On top of that, there is a method called empty RDD. Then whatever the return type or whatever the output I'll get, that is also RDD. RDD, let me give the name as RDD3. But make sure, guys, this is an empty RDD. It is nothing. It won't contain anything, right? Because how, for example, here it contains 1, 2, 3, 4, 5. It contains whatever the things present inside the file, the data present inside the file. But here it's empty RDD. Nothing is present, just empty file, empty thing. Okay, fine. Now the fourth one is, sorry, D. Yeah. What is the D? From existing RDD. From existing RDD. That's what do you mean by from existing RDD? Means, let's say I have already a RDD present, like this, the first step, whatever I follow. From this, I will create another RDD. Is it possible? Yes, I can. It's possible. How to do that? Let me use that. Okay. So let me highlight this one. So here I am using empty RDD. Fine. Now here what will happen, guys? Again, I'm writing the same thing. That is how I will clear the existing. So when I'm telling from existing RDD, that means first one RDD is existing. So how I will make it exist? Let me create this one. C dot parallelized, parallelized. Let's say I'm passing the same 1, 2, 3, 4, 5. Now as you know, we have already seen this one, it will create a RDD, right? So this is RDD called RDD. Now what I'll do on top of this RDD, because this is my existing RDD now. Now on top of this RDD, I will use different transformation operations. So one of the transformation operations is map. Let me use. What is transformation? What is action? I will explain everything in details. Nothing to be worried. Then I have to pass. I have to write the logic. For example, I am writing the logic. Let's say lambda x, where x is nothing but element of each and every element of RDD. That too I will multiply with 2. That will be the output of my final RDD. So let's say this name I'm giving you. What is that? So RDD3, right? Let me give you RDD4. So guys, what you are using here, you are using a transformation actually. That's you are creating the existing RDD, no doubt you are using parallelize method. On top of the RDD means you can correlate. So this is nothing but my this one. Where I bring this one. So this RDD I'm using here. On top of that, I'm implementing map. I'm writing some logic that is giving me another RDD, that's RDD4. Yes or no, guys? So what is the output? If you tell me output, let me write down here just for your knowledge check. Let me change the color. See here, my RDD contains 1, 2, 3, 4, 5. I have written a logic. This is a lambda function that x means each and every element of this RDD. Multiply the 2, then that is the output of RDD. Now you tell me, now first element is 1. 1 into 2 is how much? 2. Now second element is 2. 2 into 2 is how much? 4. Now third element 3. 3 into 2 is how much? 6. Then 4. 4 into 2 is how much? 8. Now 5. 5 into 2 how much? 10. Now this will be the output of RDD4. Getting my point? But what is the output of RDD? That is same. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Getting my point, guys? This is the output of RDD. But on top of that, when I implement this logic, now the final output of RDD4 is equal to 2, 4, 6, 8. Because I'm implementing, I'm multiplying 2. If you multiply 5, then it will be 5 times. I mean, just multiply 5. That's all. Clear? Now, the fifth one is from the database. E. From the database. How I will create a RDD from database. For example, there is certain data present in the database. For that, what I will do, I'm writing sc dot again sc. That is very important. Dot read method, because I'm trying to read or extract the data. For example, I am here. I'm trying to extract the data from MySQL database. Any database you can extract. Okay. So let me here. I want to extract from MySQL database. Then I have to write the logic like this is the code JDBC colon. Okay. This is syntax basically. Okay. MySQL colon localhost colon port number, any port number. So let me here I'm taking the port number of my MySQL whatever I have installed in my machine. Okay, then colon slash db the database name. Okay, database name. Then I have to pass the table name from which table I want to extract. If I write this, then it will return a RDD that is called RDD. Let's say 5. Yeah, these are the typical 5 different way how I can create RDD. See, that's the beauty. First one, I told you. What is that? Yeah, by using parallelize method, sc.parallelize method. By using loading a file, text file from empty RDD method. Then existing RDD, I'm using a map, that is a transformation. Then from database, I'm using the read. Clear, guys? Any doubts so far? Any doubts so far? Any doubts so far? Now, so before proceeding into operation on RDD, let me quickly go through my PPT and I'll show you what are the things I have explained in the whiteboard. Same things to present or anything we have left. Okay, now let me just give the heading as operation on RDD, then I will go through that. Okay, operation on RDD. Let me show it on point actually. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, fine. So before proceeding, let me go through. Yeah. Same things is written whatever I explain. See, RDD. The resilient distributed data set is the fundamental data structure of Apache Spark, which are immutable collection of objects which compute on the different node of the cluster. Each and every dataset in Spark RDD is logically partitioned across many servers so that it can be computed on different node of the cluster. Now to the next. So it is explained resilient distributed clusters. See, same things. Resilient means that is fault tolerance. Okay. Distributed, since you know that I distributed across multiple nodes. Data set is nothing but it's a collection of different data where that is in different file format, maybe CSV file format, JSON file format, text file format, and all. Okay. Now this one will come. What are the different operations we are implementing? Now see, creating the update as I told you, right? I'm using the parallelize method. I'm passing certain list value or tuple value or set value, whatever it may be. Then it's getting the update. Then load a file. I'm using text file, any file name that is text format, creating entity. Similarly, from empty entity, I'm using, you can use empty entity function or a method to create empty entity. Yes, or empty entity, that's all. Create an entity from existing entity or another entity. You can use map function to create an entity from another entity. The map function take a function as argument, see? And this function is applied to each element of the entity and the result are collected into a new entity, that entity. Now, from the database itself, create an entity from a database, you can use the read function to create an entity from a database. That is read function takes the JDBC URL to the database as its argument. Okay, that's all about the creation of entity. Clear, guys? Now let's come back to our whiteboard. Okay. So now operational entity. Now coming to entity, guys, we are basically implemented two different operation, which is very important. That is called, one is called transformation. Let me use a different color. Another one is called action. Now coming to transformation, guys, we have different transformations out there. And what is transformation, what is action, and all each and everything I'll explain one by one, nothing to be worried. Okay, so now mainly transformation and another one is called action. Okay, so coming to let's say let me give some certain example of transformation and action, then I will explain one by one. Okay, fine. So just 1 minute, guys. Let me see where we are. Okay. Mm, okay. Yeah. Now coming to transformation, let me write an example as I have written in the above also. One is called here map. Another one is called, let's say, filter. Okay, filter, map, filter. Then another one is called reduce. So these are the example of transformation. Don't think that only three. I mean, a lot of things are there. I'm just writing three. Similarly, sir, could you please give some example of action? Yes, why not? There is something called count, collect. So then I can say then what else? Count, then collect, then I can say save as a text file. Okay, take, save as text file. These are the example of, guys, action. Then sir, what is transformation and action? Okay, let me give an example. Guys, transformation is something, unless, I mean, just it's a kind of thing about a task it's doing, but you will not see the output. Unless and until you implement action, you cannot see the output of the transformation. Sir, could you please give an example? Yes, best example let me give. Think about whenever you are going to any Xerox shop, okay, to do some Xerox. You might have seen two different scenarios. I'm explaining you. You can correlate. You will be shocked. Yeah, really. That is a fantastic example. What I was suggesting. You might have seen some Xerox which is very new. That person is very new operator. He or she does not know much about the trickiest part of how a Xerox machine works. So, for example, you are given a notebook of your friend to make it Xerox and which contains 100 copies. I have seen people who are new, they have opened the shop newly or they does not have much experience. What they are doing? Fast page, they will take the scan, you might have seen. So they will just take the fast copy, put that upper portion down, click button, so it will be scanning. Okay. Then click on print option, one printer will come. Second time they will make it second pages, scanning, then print option, it will come. So in this case, generally what happens, you are doing fast, let's say scanning. So let me check the color. Scanning, then print out. Then again scanning of past page, right? Scanning page one, then print out page one. Scanning page two, print out page two. And similarly, it will go. 100 times, 100 times you will press the scanning button. 100 times you will put the printout option. Second option is, guys, you might have seen there is an old person. Looks like very old. The shop is looks like old. Means it's a kind of experienced fellow. What you'll do, you might have observed. This is really a very interesting example. You take your note, first take the first page, scanning of first page one. Then you'll turn it, scanning of page two, scanning of page three. Like this, you will do all the scanning first of 100 pages. At the end, you will just press the print option, print out option or print option. Then automatically, lot of pages will come automatically. All the 100 pages printout will come. Are you getting that? What is the this is the optimum solution? I can say optimum solution. Why? Because here he click on scanning button 100 times. He click on print up button 100 times. Means totally 200 times he press it. Tuck tuck tuck. Then one pages will coming. First page it will hand over to you. Second page hand over to you. Third page hand over to you. It's a kind of fresher kind of work. But the person who is experienced person, okay, you will ask, okay, you need one copy or two copy. Two copy also you will give at a time. Two printer will come. So it's a one copy will come. Fantastic. Now first you will do the scanning of all the pages. Page one, page two, page three. Just at the end, you will press the print button. Here in this case, what happens? 100 times scanning page, you will press. Just one time printout option. So it will be just one, not one. 101 times press the button. But here, 200 times you press the button. So obviously this is the optimum solution. Now this is not our job. This is the optimum solution. Now my question is, my intention is to give the answer is, guys, even though you are doing 100 pages scanning, 200 pages scanning, unless and until you press the print button, you will not get the printout. Are you getting my point? Even though just do 1000, 1 lakh scanning pages also, do you think that you will get a printout? No. Unless and until you press on the print button. You press the print button. There is a print button, right? Big button will be there. There is written print. You press on print button, then only printout will come. That means here, all the scanning operation, whether you are doing for a first principle or second principle, scanning printout, scanning printout, scanning printout, or maybe scanning. In every cases, first case or second case, scanning is nothing but kind of think about it's a kind of transformation. TRANS transformation. Print here about action. Getting my point, let me scroll it up. So, even though you are doing scanning of 100 pages, you will not get the output first of all. You will get the output only when you will click on the action button, that is print button. So that is called action. So that is the difference between transformation and action. For example, implement map, you implement filter, you implement reduce. What is the output of the reduce? What is the output of filter? What is the output of map? You will not get. Unless and until you execute some action. It may be any action, maybe store, maybe take, maybe collect, maybe count, whatever it may be. That is the difference between transformation action. Any doubt so far? Please let me know. Any doubt so far? Any doubt? Now let me share my screen. Happy PPT. Say, beautiful example. Not transformation. Transformation are operation that create new entity from existing entity. Like as I told you, we are using map. By using map, we are able to create a new entity. Some common transformation include map, filter, and reduce. So I am showing you the map. By using map, how you are creating a new entity from existing entity, right? Because I'm implementing lambda x colon x multiplied with 2. Now here I'll show you filter. So with this you can see two different examples also. Now see, I have tried to see different word that is Hadoop, HBase, Cassandra, Spark, and HDFS. Now I will implement a transformation called filter. My filter is condition is filter all value or word that start with H. Now guys, by seeing the word, you can see which word start with H, that is Hadoop, HBase, and HDFS. Out of 1, 2, 3, 4, 5 different word, three different words starting with H, another two words not starting with H. So I have to filter out those words. You can see as a part of output, I'm getting only these two different words, that is Cassandra and Spark. Why? Because these two words are not starting with H, getting a capital H. Clear? Because Cassandra started with C, Spark starting with S. Clear, guys? Clear. Now, similarly, let's see the example of action. Action are operation that return a value from an entity. Some common actions include count, reduce, and collect. In addition to that, some more example also: count, reduce, collect, take order, save as text file, save as sequence file, and all. So the count return the number of element in an entity. Now reduce the element of an entity to a single value using a binary function. Now collect, return all the element in an entity as a list. Now take, return the first n element of an entity. This is just an explanation, description I can say. Take order, return the first n element of an entity in order, sorted order, like ascending order or descending order. Similarly, save as text file, save an entity to a text file. Save as sequence file, save as entity to a sequence file and all. Clear, guys? Any doubts so far? Any doubts so far? If not, then come back to our whiteboard. Yeah. So we have completed successfully transformation action also. Now let's see what is lazy evaluation in Spark. Once we complete with this, we can complete it successfully the today's agenda. Okay, this is the last topic today's class. Lazy evaluation in Spark. 13. Sorry, 13 or 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Guys, what is lazy evaluation spark? Even if as part of my explanation, I have also given a hints or trick to it. As I explained just in the previous example, guys, even though I am doing the scanning for 100 pages, 200 pages, 500 pages, do you think that you will get the printout? I mean, a printout copy? No. Unless and until you press the action button, you will not get the output. That is called lazy evaluation. Means unless, unless and until, unless and until you implement actions, transformation, operation won't give any output. This mechanism is called as lazy. Lazy means you know, right? Lazy fellow. Lazy evaluation. Suppose we are telling lazy fellow. What do you mean by lazy? For example, you are a lazy person. Means unless or until your mom wake up from the bed like tell you, oh, hey, wake up. You have the morning class. Oh, I just wake up. So okay, do the tip brush, then take the breakfast. Okay, you have to go to college. Okay, college. Going to college, come back. Then you are sitting like this. Then your mom will tell, hey, just study because you have the semester exam. Then you start to study. Means every time somebody will be there to uh, guide you. Do this, do that. Is kind of lazy fellow. That's what I'm telling you, lazy fellow. It's not doing any proactive work from the mind. Okay, I have the exam. Let me start opening the book or any notes I will study. No, no responsibility. Unless and until somebody guide them, like some parents, maybe elder brother or sister, they won't do anything from their end. That is called lazy fellow. They are lazy. So this is called lazy evaluation. Okay. So unless and until you implement the action, transformation won't evaluate by their word. They won't give the output. That is called lazy evaluation. Okay. Evaluation. Clear, guys? That is called lazy evaluation. Any doubt? Any doubt? So best example, for example, let me draw a diagram. Think about it, data is present in a database. Okay, this is my database. Okay, my DB. Okay, let me draw the diagram. What I'll do, so let me write. So this is my database DB. Let's say MySQL DB. MySQL DB where data is present. Now you are loading the data. You are starting, let's say you are using RTD1. This is RTD1. Just loading the data, extracting the data. Now again from RTD1, on top of RTD1, you implement some transformation and all. So basically I can say transformation. Let's say transformation 1, it's created RTD2. Okay, fine. RTD2 has been created. Then again you implement transformation, let's say transformation 2, it will create RTD3. So RTD3 is creating on top of RTD2, right? Then finally you implement action. When you implement the action, the final result actually you are able to see here, the output result. So this means even though you are implementing lakhs, infinite number of transformation, it has no use unless or until you implement the action. Once you implement the action, then only you can see the result. And what is the sequence of implement the action? One person asked me in my last batch, last year batch. Excellent question, sir. Could you please tell me what is the sequence of execution? The sequence of execution will be, for example, I have three transformation or two transformation. Let's say transformation one, transformation two, then let's say action, one action or action one or action. Sir, there are different ways. So first I will execute transformation one, then transformation two, then action. Then can I execute transformation one, then action, then transformation two? Sir, can I execute first transformation two, then action, then transformation one? Sir, can I execute first action, then transformation one, then transformation two? These are possible. This is a different permutation and combination. Sir, can I use transformation two, then transformation one, then action? Yes. Or can I use any other combination, guys? I have already covered everything, right? Because no other combination you can find out. T2, T1, this one, this one, this one. Okay, A first. Okay, fine. So out of all these combinations, let me see which one is valid. Okay. Guys, whenever you implement the action or transformation, remember, always you have to implement all the transformation first, then you can implement the action. Like how? That's why I'm drawing this beautiful diagram. So here implement action. So without implementing transformation, what is the use of implement action? Think about. Let's say I have not scanned your copy, just press the print button. Do you think that printer will come? No, because I have not done any scanning of your notebook. Then what type of printer will come? Nothing. It's empty, right? So this is invalid. Fast action, then transformation is invalid. Similarly, sir, I am doing transformation, then action, then again another transformation. Then what's about the action? Another action, no action. So this is also not valid because you will get output of only T2. What's about T1? Let's say you are getting the output of page 1. What's about page 2? You will not get page 2 because here should be another action. So this is not valid. So here also, like for example T1, let's say page 1, then action, okay, page 1 print out, like in the past case. See, past case here. Where is that? Where is that? My example of printing. Yeah, here. Scanning of first page, print out, okay, you got. Scanning of second page, but you are not doing a print out because you are not doing an action. So you will get the output of only page 1. Then what's of page 2? You will not get. So this is not valid. Now, sir, I'm doing the scanning of page 1, then page 2, then action. Then you will get page 1 and page 2 both. Then this is valid. Sir, I'm doing the scanning of page 2 first, then page 1, then you are printing action. That is also fine. You will get the printout of page 1 and page 2. This is also valid. So what you understand from these 2 points, first, always I implement all the transformation. Whatever the number of transformation. For example, you have 10 number of transformation like T1, T2, T3, up to T10. Then action. Then you implement first T1 to T10, then action. This arrangement may be different. Maybe first one is T10, then T8, then T9, then T2, then T4. That is fine. I don't have any issue. But make sure unless and until you implement all the transformation, don't implement action in between that. Let's say action here, action here. No, don't do like that. This is not the optimum solution. That's why I give you the example before in hand. This is the optimum solution. Why? Because I'm implementing the action at the end. That is print button. After completion of all the scanning, it's better because I'm just pressing only one, not one press button. But if you do like that, you have to press more number of times, but make sure after doing scanning you have the print option. If you don't print, that particular page will not print out. Are you getting my point? That's why it's always recommended to implement all the action, all the transformation first, then action. That's why the first stage and this one is valid, but other are not valid because I'm implementing action somewhere either fast or in between this. Getting my point, guys? Any doubt so far? Any doubt so far? So let me quickly jump in. Let me explain one more time here. Sorry. Lazy evaluation. Are did as lazily evaluated, which means that they are not evaluated until they are needed. This makes RDD more efficient to work with, and they are only evaluated once, even if they are used multiple times. See, multiple times I'm using RDD, 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 but they are evaluating only once. When? When I implement action, let me maximize it. See, storage. So some data storage or database. Now RDD created by reading data from the stable storage. Now RDD 1. Then I implemented transformation 1. Then creating RDD 2. Implement another transformation. Then RDD 3. Finally, I am implementing action. Then only you are able to see the result. Getting my point? So unless and until you implement the action, you will not see the result. It will be kind of another identity like identity 4. For example, think here I am implementing transformation, again identity 4. Then another transformation, identity 5. It will keep on going like that identity 10, identity 100 and all. But once you implement the action, then only you will be able to see the result. Now, what is the sequence here? Now, all the transformation you are implementing, then only you are implementing the action. If you will not follow this order, there's a first action, then transformation, or transformation, then action, then transformation. That is not the valid syntax. That is not the valid syntax altogether. Getting my point, guys? Getting my point?